So welcome everybody to our lab session for this week. It is June 10th, so it's technically the last day of class. And again, by that I mean it's the last day of official class, so I will have to be turning in the paperwork to school for this class ending. But as we know, we are extending our work in NetAcad and on NetLabs until our class starts on July 27th, which will be for our CCNA 2 course. So all of you are going to continue to work as we move forward. One of the things I want to do today, I've already put out, if you look inside of our the NetAcad class, I did put out a series of extensions, or actually a kind of an update to the, actually that's the wrong class. I went to the wrong class there, sorry. I have multiple classes, so I got stuff that needs to be graded in both, but I need to be in my spring class, not in my summer class. Your class technically started in the spring, but you'll notice I did a syllabus revision for the class extension. So I put in new dates that are available for you to see when the modules are due. And technically this week and next, we're actually working on module 11. So what we're working on today falls within those new dates. If you've been working along and you are ready to take the final exam and you're ready to do everything, let me know and I'll get you set up to go ahead and do the hands-on final in NetLabs, and I'll get the written final on for you. But I think for most folks, you're probably behind and you're going to need this next couple of weeks for us to catch up and get ready to go with CCNA 2. I'm going to turn off my video, folks, because that way it won't show up on the screen. So today, one of the first things I wanted to do is I wanted to look at the lab 1166, because this is a written lab and it's all about calculating IPv4 subnet. So we're still talking about that. And I know you're probably getting tired of it, but it's important that you understand how important subnetting is for CCNA 1. It is one of the primary 3 items, I would say, inside of CCNA 1. The others would be configuring a router and switch, basic configuring router switch configuration. And then I would say just overall understanding of the OSI model and networking in general and how packets are encapsulated and de-encapsulated. That would be my big 3 for CCNA 1. But I want you to look at this question, and we're going to look at some of the things they're going to ask you in this particular lab. And I want to first off remind you of something that we talked about, but we didn't stress quite as much. So if I give you this, okay, this particular host IP address and this particular mask, one of the questions would be, what network would this original mask, would this host be on? How would you figure that out? If I just give you an IP address, so let's just say I give you an IP address of 10.10.10.1 with a /16 mask. And I said, tell me what network that is on. What is the correct way to determine what network an IP address is on? Does anybody remember that?
To use the VLMS.
You were very low. Say that again.
VLSM.
No, it's not VLSM. It's not variable length subnet masking. This is going all the way back, just looking at IP addressing. You remember the concept of ANDing.
Oh, I know.
If you ever are given an IP address and a mask, and they want to know what network that IP address is on, what you do is you convert the IP address to binary. So 1, 2, 3, 4, 1, 0, 1, 0. Okay. Dot 1, 2, 3, 4, 5, 6, 7, 8. And then I do 1, 2, 3, 4, 5, 6, 7, 8. That's 10. 1, 2, 3. All right, so there's my IP address in binary. So you convert your decimal address to binary. Then you put the mask in binary. And you AND those two together. And if you remember, the mathematical process of ANDing is the following. If you put a 1 and a 1 together, you get a 1. Put a 1 and a 0, or actually anything else, you get a 0. Okay, so let's look at what falls through here. So let's go through and just look. So we end up with 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0. Like I said, I wish I had $1 for every time I put a 1 or a 0 on any kind of sheet. Oop, short there. And you'll see that this is the 10.0.0.0/16 network, which you knew already because it's a /16, and you knew that this portion was the network portion. Sometimes, however, it's not that easy to see. So let's imagine this scenario. Let's imagine we've got this IP address. Let's imagine we've got 10, 10, 10, 35/27. Now, what subnet is this on? Now, I'm going to go ahead and get you to agree with me. All right, it's pretty easy to do. We know for a fact that this portion is going to fall through as 10, 10, 10. All right, we know that. So I'm not even going to bother converting that to binary and then ANDing it. We're just going to AND this final octet. So let's take 35. So 128, 64, 32 is on, 16, 8, 4, 2, 1. And then 27. Okay, so in our last octet, we've got 3 bits turn on, 1, 2, 3, 4, 5, 6, 7, 8. And we're going to learn that what falls through is 001, 00000, which is 32. So this is the 10, 10, 10.32/27 subnet. So that's the network it comes in. Why is this important? It's important because every time 2 hosts send something to one another, the sending host ANDs its configured IP address with its mask to find out what network it's on. It then ANDs the destination with the configured subnet mask on the sending machine to see if they're on the same network. If they're on the same network, it tries to send it directly. If it doesn't, then it sends it to the default gateway. So looking at our example here that we have, our example right here, this is our host address, 192.168.200.139. And the original subnet mask is this. So this tells us if we were to AND this 255.255.255.0 to this network or to this number, we know we are on the 192.168.200.0/24 network. So that's the network we're starting at. Now, what they're wanting you to do, though, they're wanting you to do this. They're wanting you to say, we want you to subnet this to have a /27. The easiest way to do this is to look at the 3rd octet and say, okay, it was /24, now it's /27. So if I do that, I turn on 3 bits in the 3rd octet, 4, 5, 6, 7, 8. I find out my variable right here is 32. All right. So the number of subnet bits, how many subnet bits do we have? Okay. We had 24 network bits. If we use this new subnet mask of 255.255.255.224, how many subnet bits do we have? All right, y'all, you're gonna have to be a little more interactive here. Otherwise, it's gonna be real boring me talking to myself. We had 24 subnet bits, or we had 24 network bits here. If we go to this new mask, how many did we borrow? The answer is 3. We borrowed 3 bits. That's how we get this 224, that 110.111.0.0.0.0. Okay. Number of subnets created. Remember our formula? 2 to the n equals number of subnets. Oops, hit the wrong button there. Number of subnets. What's 2 to the 3rd power?
That's 8.
8. So we got 8 subnets. So we borrowed 3 bits. We have 8 subnets. that we're creating now. How many hosts are there per subnet? Remember, our formula for that is 2 to the h minus 2 equals number of usable hosts. So how many we got here?
That's 32 minus 2.
If we borrowed 3, we had 8 total. We borrowed 3. That leaves us 2 to the 5th minus 2, which is going to be 30 hosts, right? So if we borrow 3 bits, we get 8 subnets of 30 hosts. Now, once we know this, it starts talking about what is the first host on this subnet, IP address of the first host on the subnet. What we can do now is we know our variable is this 32. So our ranges are 0 to 31, 32 to 63, 64 to 95, 96, all the way up. So if we looked at this, we keep going all the way down, we have 8 subnets. But it says the IP address of the first host on this subnet would be .1. Actually, on this one for the 239, if you were wanting to find where 239 or 139 was, you'd have to keep going, wouldn't you? So what's 96? It's 128. It's 127. I believe that's right. 678. Yep. And then this is 160, 159. 191, 192, that's 223. So this is every single one of our subnets here. Should be 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's our 8 subnets we created by borrowing 3 bits. This IP address, if they're wanting you to find what subnet this 139 is in, you would go down here and find and say that 139 is in this subnet right here, the 128 subnet. And so you would say the first usable IP address in this subnet is .129/27. The last usable one would be .158/27, because we're looking at this subnet right here. Why, by the way, is the first address not usable and the last address not usable? That's what they're asking you right here. The network address of this subnet is this first number. So we can't use this number on a host because in this number, all the host bits are zeros. And we cannot use this 159 number because here, all the host bits are ones. And so the network address, what you would put right there in this particular setup would be 192.168.200.128/27, and the broadcast is 192.168.200.159. So what they're wanting you to do is take this network and then subnet it for the number of bits they're showing you here. Questions? I've got the chat up too if you want to put anything in chat, or if you have questions, you can put it in chat if you don't want to come off mute for some reason.
Professor Cottle.
Yes.
I'm going to show my ignorance here. I
Okay.
can follow when you go from 0.32 to 0.63, because the next one will be 64.
Yep.
Then from 64, the next one will be 128. And then, but you broke it down into 2 subparts, 0.64 to 0.95, and then 0.96 to 1.127.
Right.
Can you just refresh what's the rationale?
Yep.
I probably know.
Remember up here, since we borrowed 3 bits,
Oh,
our variable is 32. So we have to break down our subnets by that variable.
all right. Oh, perfect, perfect.
So you'll notice if you do everything on the left-hand side is an increment of 32.
Yeah, yeah. All right.
And
Thanks.
the same on the right.
That makes sense.
The other thing I'll also remind you of this, if you're doing your subnets, the network number should always be an even number and the broadcast number should always be an odd number. So if you're doing them and that's not true, you've done your math wrong. But that's why we're using that variable right there.
Got it. Thank you.
No problem. Good question. Excellent question. So let's go back and make another whiteboard here. Let's look at this second one. This second one is asking you to look at a 10 network. It's asking you to look at the network 10.0.0.0/8, okay? Because that's what this original mask was. But then what they want you to do is they want you to say, okay, you've got that, but we want you to get a new mask of this. So we're going to ask you, you had a /8 before, but you're going to borrow 8 plus one more. You're going to borrow 9 subnetwork bits. So this first item would be, you have 9 subnet bits. Okay. Then what you would need to do, it says the number of subnets created. Well, you would do 2 to the 9th. And that will equal your number of subnets, which should be, was that 512? I think that's 512 subnets. I believe that's correct. Because 2 to the 7th or 2 to the 8th is 256. So it should be 512. I believe that's correct. If I'm wrong there, please somebody stop me. And it says number of hosts per subnet. Well, that one you have to look in here and say, okay, we've got 8 plus 7. So we got 15 host bits. So we got a lot of host bits left. 2 to the 15th minus 2. I'm not going to do the math on that, but 2 to the 15th minus 2 equals your number of hosts per subnet. And then we've got to find our variables. And that's a little bit tricky here, but not too bad because we've got 2 variables. We're going to have a variable in the third octet, or second octet, and the third octet. So our variable in the second octet, you'll notice since it's all turned on, 1, 2, 3, 4, 5, 6, 7, 8. And then our third octet is 1, 2, 3, 4, 5, 6, 7, 8. And we didn't borrow anything at all from the fourth octet. So we got no variable in the fourth octet. Our variable in the third octet is 128. Our variable in the second octet is 1. And I'll show you why that's important. So what I do now is I just do my subnetting. So 10.0.0.0 to 10.0. Remember, on the third octet, we're going by 128, 127.255. And we go 10.0.128.0 to 10.0.255.255. Now here's where it's important. You've rolled the third octet through all the possible permutations from 0 to 255. So now you're going to look over and roll the second octet by the second octet variable. So now it goes 10.1.0.0 to 10.1.127.255 and 10.1.128. Now the problem with this question is they're asking you to go to an absurd level to get that number. So I really think that this question is a bit overkill, because you would literally have to go all the way up to, let's see, this will be 10.101.0.0 to 10.101.127.255. Now, the reason the way I get that is because just knowing that every single octet, you know, it's going to be 10 from here, be 10.101.128.0 because I've established my ranges here. So I know the subnet that this number right here comes out of, this 228, is actually this subnet right here. Okay, oops. I did that. Don't give me a red pen thing. There we go. All right, so that's the subnet it's out of, because the 101.99. Okay, so that would tell me that that's the actual network address would be 10.101.0.0/. You'll notice that the slash notation now is 16 plus 1, 17. So this is a /17 notation. The first usable address would be 10.101.0.1. The last usable address would be 10.101.127.254. All right. Questions about that one? And so what they want you to be able to do is to look at these numbers and pull out the right subnets to match these particular addresses. Now, I do want to show y'all something that is going to make you very, very happy. And that is this. Once you finish the class, you're going to have access to resources. So if, for instance, you were doing this lab, all right, so this is lab 11, it's 1166. So a lab 1166, if you happen to not know the answer, you can just go in here and find lab 1166. I don't even see it on here though. It's not on this one. It's in the other documents. But this would allow you to do the labs and see what the actual answer should be. But this is an excellent little lab. And it's just asking you to use your subnetting knowledge and apply it to subnet mask and how they work. Quick question. Let's just go through real quickly. I want to ask you this. How many bits are being borrowed right here in this problem 4? If I went from a 255.255.255.0 mask, which is a standard class C, to this 255.255.255.252, how many bits are being borrowed? So that would be my number of subnet bits. How many are there?
3.
I didn't hear you if somebody said something.
I say 3.
It's not 3. Take 252 and convert it to binary. What is 252 in binary? That's in binary. So if we have 255, we started with 255.255.255.0, which equals a 24-bit mask. So that would have been a /24. We're changing to 255.255.252, which is now going to be a /30. What's the difference in bits here? 6 bits. So we got 6 bits turned on in that new mask. What's our variable in the 4th octet? What's our magic number? Remember how to get the magic number? You go to the octet where you borrowed bits, find the last high order bit turned on, and then the value at that position, 1, 2, 4. So the variable is 4. So these subnets are 0 to 3, 4 to 7, 8 to 11, all the way up, 12 to 15, so on and so forth. And it's 2 to the 6th number of subnets. All right. Let's try something different. Let's back up just a second. Let's take and go back over the 7 holy steps of subnetting and actually let's do it with the magic number version. Let's go back into the curriculum here. Let me find the curriculum. Let me go back. And I went way too far. All right. Okay. Remember, one of the things they try to teach you is they're trying to teach you to create subnets using a magic number or using the magic number along an octet boundary. So in other words, looking at how you could borrow bits on a boundary and then looking at the magic number for each one of those. So as we look here, if you borrow into the 4th octet, if you borrow 1 bit, your magic number is 128. Okay, because that's the high order bit turned on. Let me try something, see if I can. Yep, so that's the high order bit turned on. If you borrow, sorry, I got a massive screen up over here. If you borrow 2 bits, okay, you'll notice the high order bit, the second high order bit turned on, your variable would be 64. Borrow 3 bits, your magic number is 32. 4 bits, 16, 8, 4. Now, you can never borrow more than, you can never have a mask of more than /30. And that is because of our formula for the number of hosts on a subnet, 2 to the h minus 2. You've always got to have at least 2 host bits, otherwise you won't have any hosts that are usable on the subnet. So when we're looking at typical subnetting, we're going to look at it, we're going to say, okay, I've got this network. Oops, wrong color. Let me change my colors. So I've got 192.168.200.0/24. This is 0/24. I want to subnet it so that I have 5 subnets, or at least 5 subnets. There's a bunch of ways you can do this. Obviously, you can use my 7 holy steps of subnetting, which is simply, or you can just use the shortened method and say, okay, how many bits would I have to borrow to get at least 5 subnets, at least 5? Just borrow what it, all right, now let's go over here. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 4, 2 to the 5. So that's 1, 2, 4, 8, 16. Actually, I got that all messed up. Hold on. My math is way off. That was messy. 2 to the 0 equals 1. 2 to the 1 equals 2. 2 to the 2 equals 4. 2 to the 3 equals 8. 2 to the 4 equals 16. All right, so now, how many bits would I need to borrow to get at least 5 subnets? N would have to equal what? 3, right? Okay. So we've got 8 host bits here we can play with. That's what we have in our original network. So turn 3 of them on. All right. Now go and find the highest order bit turned on. That's going to give you a magic number, or what I call the variable. What is the variable here? What's the value at this bit position?
120.
It's 32.
That's 32.
32, because 2 to the 0 is here, 2 to the 1, 2 to 3, 4, and 5. So 2 to the 5th, 32. So that's our variable. So now what we do is we take our major network number, and I'm shortening the 7 holy steps because we can use that variable to get our subnets. You'll notice it's exactly what we did before.
67.
Be 95, wouldn't it? Because it's 96. 127, 128, 159, 160, 192, 223, 224 to 255. There should be 8 here. 1, 2, 3, 4, 5, 6, 7, 8. 8 subnets. So you'll see that's how I do it. I go and figure out the number of bits I need to borrow. I borrow them from my host bits, because subnetting is the process of borrowing host bits to increase our number of network bits. I then break my network down by that value, and that's my 8 subnets. Now this is classical traditional subnetting. My new mask would be /27, because I had 24 before. I borrowed 3 bits, that's 27. And every single one of these are /27s, because we created a classical subnetting scheme. They're all the same size. They're no different. So at this point, we're still not even, we're not doing Blsm. We're going to play with that in just a minute.
All right. Professor Cotter,
Yes.
in your example, you have 1110000,
Yep.
and then you underline the 1, which is the third one.
Correct.
That is the position, 6th position. Shouldn't that be 64? Because
No.
2 to the 6 is 64.
But remember, this is 2 to the 0,
Yeah.
2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4.
Oh, all right, I got it. Okay, okay. Thanks.
Yep.
Yes, yeah. All right.
So it's a 32 position.
Yes.
No problem. And, well, my handwriting's so bad it's hard to see anyway. I apologize for my handwriting. It's horrible. So let's go over here and let's try something different. Let's do this. Let's try 10 dot, well, golly, talk about terrible handwriting. Woo wee. All right, so let's try 10.0.0.0/8. And I want same thing. I want 5 subnets. I forgot 2 to 2, didn't I? Golly, I'm messing up today, y'all. Sorry. Two to the 1, 2 to the 2, 2 to the 3. All right, so there we go. So let's do this again. Let's look at it. 1, 2, 4, 8. So I want 5 subnets again. So 2 to the 3rd equals 8. So we're going to borrow 3 bits. But notice this is totally different. We now have 24 host bits we can play with. We're still only going to borrow 3 of them. So we sit here and we go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. And we're going to go find our highest order bit turned on. Our variable is still 32. And so now watch what happens to our ranges. This is the only thing that really changes is our range in the second octet is this. And notice we rolled our these 2 octets are as far as they could possibly go. So now we're going to go and roll and then 10.64.0.0, and it would just continue on just like we did before. So there's 95, 255, 255, all the way till we get our 8 subnets. Oops, 255. Because we borrowed nothing from the 3rd and 4th octet, they stay unchanged. They just roll their entire version or entire possible permutations, which is 0 to 255 for any octet. It's 223. On down to 10.224.0.0 to 10.255.255.25. 1, 2, 3, 4, 5, 6. Oh, I missed something somewhere. I missed a subnet. 696. Oh, right there. I missed one in here. Sorry, y'all. I messed up right there. Oops. Y'all should have stopped me. Y'all get the gist. I'm not going to write them back out. Y'all get the gist. It's the same thing again, just all the way down through. Okay, it'd be 0, 32, 64, 96. So using the 32, 64, 96, 128, 160. That's what I missed. 191 and 220. Oh, 192, 224, 1, 2, 3, 4, 5, 6, 7, 8. There's our 8. Those are the 8 subnets there that are part of this when you borrow 3 bits. But you'll notice it was a /8 to begin with, and now we borrowed 3 bits. What would it be? All of these would be / If we borrow 3 bits, we started with 8, being 11. So these are /11s. So it really, nothing changes. You find that magic number and you roll your octets by that magic number. you'll notice, or you should be noticing, whenever we're subnetting classfully, we're subnetting based on the number of subnets we need. That is in stark difference to what we do when we're doing Blsm. When we're doing Blsm, we're actually doing it based upon the number of hosts that are needed. So we do it backwards. We do it by the number of hosts, not the number of subnets. Questions? I want to go ahead and jump over to lab, let's see, 11.10.2. Okay, I'm getting this lab real quick, 11.10.2. I'm not going to have time to. Okay, so here's the lab that we've got. And what they want you to do is, obviously, we've got this network, and we are going to subnet it for the requirements that are here. Now, what it's going to ask you first, it says examine the requirements. So let's look at this lab. And it says, first off, how many host addresses are available in a /25 network? Well, first off, you should be able to figure this out just using the formula. A typical IPv4 address is 32 bits, correct? Everybody agree with me on that? So if there's a /25, that means there are 7 host bits left. So 2 to the 7th equals 126 hosts on each network, because remember our formula for hosts is 2 to the h minus 2 equals the number of usable hosts. So if we have a /25, that means we have 7 host bits. So it's 128 minus 2, 128 minus 2, which gives us 126 hosts. If we have a /26, it means we have 6 host bits, which should give us 62 hosts. What about a /30? How many host bits are left?
2 to the 8.
It'd be 2 to the 2nd power,
Wait.
because there's only 2 host bits left. Remember, this tells you how many network bits you have. If you have 30 network bits, you've only got 2 host bits left. So it'd be 2 to the 2nd, so it'd be 4 minus 2. So with a /30, there's only 2 possible hosts per subnet. So that when they ask you this, how many hosts are available on a /25 network? The correct way to find that is go 2 to the h minus 2 equals the number of hosts. And since it's /25, we had 7 left. 2 to the 7 minus 2 is 126 hosts per subnet, right? What is the total number of host addresses needed in the topology diagram? So we'll go up here and you would just add up the numbers. So 40, 42, that's 9, 13, so 55, 65, 75, 80. Looks like there's 80 hosts necessary for this particular one. How many subnets are needed in the topology? Well, in this particular topology, we would need 1 for every interface. So 1 right here on the G001, 1 on the shared G000s from B1, BR1, BR2, and 1 for the G0001. But we also need 3 future networks. So there's 1, 2, 3, 4, 5, 6. 6 subnets will be needed because of these 3 right here that are listed, but not actually shown in the diagram. So it'll be 6. Determine the largest subnet. Now we look here, our largest subnet is going to be this BR1 LAN, which is 40 hosts. All right. So let's go back out and look. They've given us the network. They've given us the network 192.168.33.128/25. In fact, they've already subnetted for us one time. They're giving us a subnet of a network already. Because if you'll see, this is 128 to 255. All right, because it's a /25 and our variable there is 128. we need to subnet this down to support 40 hosts. Right now it supports 126 hosts on each network. So what I would say to do is take this, borrow one more bit, /26. And remember, our variable goes from being 128 at /25. Our variable is now 64. So we get 128 to 191 and 192 to 255. So we broke this subnet down by borrowing one more bit. We would then just go and borrow another bit, /27, where our variable becomes 32. Let's go 128, okay, to 159 and 160 to 191. Now you really don't have to touch this one right here now, but let's look. Sorry, all my phone's ringing. So right now I'm going to leave that. I'm not going to touch it. By rule, what Cisco wants us to do, Cisco wants us to pull this network out right here. Okay. So Cisco says, if you follow what the curriculum says, we would pull out 192, 168, 33.128/27 for our network of 40 hosts. And actually, you can't go any smaller than that, because if you go to /28, there's only 30 hosts per subnet. This is 60 hosts per subnet. So we'd pull that out, and this would be the network used for BR1 LAN. Okay. Now we look for BR2 LAN of 25 hosts. So what I would do now is we pulled this out. So we got to leave this out. We can't use this again, so it's gone. But we can borrow another. Okay, so /28. Okay, 26, 27, 28. So this is now 32. So this would go 160. 31B to actually I'm 128, 6 by 30, 16. Sorry, 16. Not. Oops. Okay. So we've had our variable right here is 128. We know that because it's /25, so that's our variable. Our variable here is 64. Our variable here is 32. Our variable at /28 is 16. So we've got to break this apart by 16. So it'll be 160 and let's see, 16, 176. And this is 175, which is a really weird subnet, but it is one. And then now we could pull this out to be our network with 25 hosts. And then we would just keep subnetting this down to meet the needs of our network. This is Blsm. This is subnetting a subnet. Subnetting a subnet. So we're taking and breaking it down so that it matches exactly what is needed for each one of the networks. So now it's 192.168.33.160/28. And this would be for the BR2 LAN. And then we would just continue here. We'd take this 176 to 191 and do a /29. Our variable then would be 8. And we would just continue on, so forth, until we have all of them subnetted. Questions about that? Oh, my pen was on the thing. Okay. Let me grab something here and make sure. And let's do. Okay, so make sure my numbers are right. Yep, 160 to 175 is indeed correct, and 176 to 191 is indeed correct. And then if I took it down another level, if I went down one more, okay, so I did a /29, we would do 176 to 183. So this would be 176 to 183, and 184 to to 191. Yep. And then that would be at /29. Now we're getting closer to the levels of, okay, so /29, there's 8 bits here. So there's 2 to the 6. There's only 3 bits left. So that's as far as you could go to get these 5 hosts and 4 hosts and 4 hosts. You could go one more to get the 4 hosts, but I would probably pull this out to do the 5 hosts. And then you could go ahead and continue to pull them out from other things too. So that would give you the one with the 5 hosts. So 192.168.33.176/29. And that would be for the BR2 IoT. Just remember what I've taught you about real world versus book world. In the book world, when it says, you know, design it for this, that's what I would do it. In the real world, I would design it for at least 3 times these number of hosts within 6 months, because networks grow at tremendous rates. And that's what this lab is trying to get you to do, is just look at how you would break this down by subnetting it each time to get what you need. And then you put that into the network. Now this one, I do know for a fact. The good news will be down the road, once you get fully accredited, this lab is definitely inside of your answer sheets. And so most labs have answer sheets, so you'll be able to go in here and look and see to make sure you've got the right networks. You can see here, BR1 LAN is the 128/25. BR2 LAN is the 192/27. So if I got that, yep. I did a 192. See what they do with it. They actually gave it a bigger numbers than what I would have. Oh, they actually used that full big one for that. Okay. They used the /25 for that one, which works, but /26 would also work. So they actually made it use the bigger number instead of that. So their numbers are slightly different than mine, but they didn't make it match as closely as I did. Okay. Questions? It is important for you to realize this right here. Answers may vary. When your students start doing Blsm, it's important to note, as long as they get the / notations correct, it's okay. All right. So if they do /26 and that works, okay, then you need to be aware that /26 is what's needed. And then what's funny though is they didn't use /26, they used /25. So I think there's a mistake here in the grading. That should be a /26, but they used it. Either way you could do it though, but both of them would work. I have to be very careful. A great example is I have the Skills USA National Contest next week. In fact, I need to remind y'all that during the day on Tuesday and Wednesday and Thursday, more than likely NetLabs will not be available because we will be running the national contest on it. So be aware of that. If you try to do a lab Tuesday, Wednesday, Thursday during the day, we'll have all the pods set aside for our national contest. But we have to be careful when we ask them to do subnetting questions, especially VLSM questions, because the answers, the actual IP addresses they pull out may not match exactly what we have put on our grading sheet. But as long as they match the correct notations, in other words, correct / notations, then we're okay. Okay. Actually, it should be a /26 there, not /27. So I think I did screw up. 25, 26. Yep, that should be a /26, not 27. So I messed that one up. And then that would also be a /27 and a 28. So I messed them up too. Sorry about that, y'all. I got thrown off because it started with /25. There's a /26, but I pulled it from the right network. I just didn't put the right mask when I put it down here. So the 128 to 191 is correct. And then this 160, actually, nope. You know what, folks? We need to redo this because I screwed up. And somebody tell me why. Somebody, y'all tell me why I messed up. I'm gonna tell you exactly why. Look what I tried to do. I made a classic mistake that so many people make. I assigned this network, okay? And then I said, okay, I assigned it. And then I went out here and tried to subnet it again. You can't do that. This network contains all of these numbers, so they are not available. So what I needed to do is once I pulled that /26 out, okay. Once I pull that /26 out, so 192.168.33.128/26, everything in that is taken from 128 to 191. So now when I did my next item, the /27, I should have been breaking down the 192. So it should have been 192, 224. So I had overlapping subnets or overlapping IP addresses. So I apologize. That is my mistake. And I'm glad I caught it because that would have confused the heck out of you. And now you can see because I pulled that top portion out, I can't use it again. I can't subnet this any further because I pulled it out to use it for that one LAN. But these two pieces down here, or that piece, I can subnet again. And I can pull this out to use with the next network. So this 192.168.33.192/27 can be used. But then I can't use anything else in this. And I can go down here and do a /28, which is 16. And I can break this down by that. So be very careful not to make the mistake I just made, which was once you pull a section out to use it, everything to the right of that is used. Now, I will show you something we many times give out to our students as they're learning Blsm. Okay, so if I can find the Blsm sheet. Yep, here it is. This is the Blsm cheat sheet. And many times we give this to our students because, oops, where'd it go? It went over here to the other side. Sorry. This is the Blsm cheat sheet right here. And you'll notice that it has all the different ranges /26/27 all the way out. Go back over here so I can get this one, a little better one. Okay, you'll see them right here. So what happens is when you use this, if you're actually using this cheat sheet, I'm gonna pull it out and show you what we do. So let's imagine I've got this sheet, Control C. And I'm doing subnetting. I'm working on Blsm. I'm working on my charts. I've got this sheet here. Well, what I do is this. So if I go and say, okay, I pulled out, in this case, I'd actually used this network right here. I use this one. Okay. You'll notice that if I use that one right there, okay, so I use this one. I use this. What we have our students do then is they take on their sheet and they mark out everything to the right, because all of that is contained inside of that. Now, we still could go down here and get 192. We could go down here and get a /27, but we can't use anything in here because every bit of that's called overlapping. It overlaps. So you're overlapping with this. So basically, as you pull pieces out, another great example, let's imagine I decide to use a reverse thing is this. Let's say I decide to use the .0 and .4 right here. Well, because those two are there, that means I can't use this. I can't use this. I can't use this, this, or this, because 0 to 7, okay, so which is what those ranges are, that's 0 to 7. Those are in these two subnets. And so you can't go back and use any other subnet that would contain those two numbers. And that's what you have to be careful of. And that's where I messed up in my example. In my example, I had pulled the 128/26 network out and then continued to use it. And you cannot do that because it's overlapping with the other addresses that were trying to be used. Okay. Is that clear? I want to make sure you understand where I messed up. Any questions on that? Everybody's super quiet. So the mistake I made was I pulled this portion out and then I continued to try to subnet it. Once you pull a subnet out, you can't subnet it again. It's in use, so I couldn't subnet it again. That's why I messed up. Okay. Let's go back. So if I had 192.168.12.0/24, okay. We know this is typically one network of hosts from 0 to 254 being usable because it's got 8 bits. All right. Let's go in and let's subnet it once, borrowing 1 bit. We go 0 to 127, 128 to 255. Okay, so we took this one network, made it 2 networks. If I needed a network of 126 hosts, I could pull this network out. Okay, and that would give me the network 192.168.12.128/25. So that is a subnet that has 126 usable hosts on it. How am I getting that number of 126 usable hosts? Anybody? The formula is 2. Yep, 2 to the h minus 2 equals the number of hosts, number of usable hosts. For the /25, how many host bits are left?
That's
There's
136.
7, because remember there's 32
yes.
total. So this would be 2 to the 7th, which is 128 minus 2, 126 usable. Yep. Okay, so borrowing 1 bit, I get 2 networks of 126 hosts. I pull this section out. This is now gone. I cannot subnet it again. That's the mistake I made on my earlier example. I tried to subnet something I had already pulled out to use somewhere. But I can do /26, break this down by 0 to 63, because now my variable is 64. And I could pull one of these out and use it, or I could continue to subnet it as need be. So I can go in here at 0 to 31, 32 to 63. And now here's the thing, I could pull this out, okay, and use it. But I want you to be very clear. Once I do that, I do 192.168.12.32/27. As soon as I pulled that out, this can no longer be used. That cannot be used because it contains 32 through 63. So as you move to the right and you pull pieces out, it also will make pieces to the left unusable because it's called overlapping. They overlap. How many hosts are in the /27 network?
30.
30. Yep, 30 hosts right there. Excellent. Very good, because it's 2 to the 5th. 32 minus 2 is 30. This is VLSM, making it match the number of hosts you need so that you don't subnet your networks in an inefficient way. Questions?
Professor Kelly,
Yes.
I only use the VLMS that they have on 11.1.3, where they have the subnet, have like the first one that have 24, the prefix for 24, which is given the same thing that they have back there. And then for 26, which is the one that they calculate next, just like
Hold on a second, Jacob. Get a little closer to Jacob. Get a little closer to your microphone.
11.1.3.
Okay. It's a
The
lab
module.
11.1.3. Packet tracer or lab?
I'm talking about the like the class that you gave to us on the Cisco.
Okay.
The module. Okay. Yeah.
Okay.
That's
Yep.
one.
All right. All right. I'll go here.
11.13.
Okay. I'll go here. 11.1.3 right here. Okay. Prefix length.
Okay. Go down. Go down. Go down.
Okay.
Okay.
Yep.
There. Okay. You see, that's the way that you see comparing the subnet mask and then prefix length.
Yep.
Like when you ask me for 27, you see there, I have I've already calculated all those one back there. So,
Yep.
and that one let me know there.
And this is a good way to remember it. I mean, the thing here too, you'll see the big thing you will see with what we're doing is typically we're going to be dealing with well, not always, but a lot of times you just need to know how to get that variable. You know, if the slash notations, yeah, remember /8 is a typical class A subnet mask. /16 is a typical class B subnet mask, and /24 is a typical class C subnet mask. And then these are borrowing into the 4th octet. They call it a prefix length because that's the number of ones turned on inside of the subnet mask. And this is where we did our anding too, where we learned about anding. Okay. Does that make sense? Does that help? Okay. We will keep working on these. We'll keep working on subnetting. We'll keep going over it. I feel like we need to do more work here. I really do. I apologize for messing up that one example. I hope I didn't cause too much confusion, but we will continue to work on these. I want you to be working on module 11 and module 11 labs. Watch these videos because sometimes watching the video helps you because they teach it in a different way than I do. As I've stressed before, many times I have to bring teachers in so that they can see what or see a different method to teach it, so that they'll understand it better than they do if I teach it to them. So watch these videos and let's come back to class on Monday with questions about module 11.
Okay.
All right. Any other questions, everybody? Thank you so much for being here. I really appreciate it. I'm glad we can have these sessions, and I hope they're useful. And as we move forward, if you want to email me and you have questions on specific labs, I'll try to do those specific labs for you too.
Okay.
All right.
Thank you.
Thank you so much, everybody. Have a great day.
Okay.
You too, Kelly.
Bye-bye.